Good afternoon, Your Serene Highness, Your Royal Highnesses, honored guests, especially Professor Chon. I'm pleased to welcome you all to the inaugural event for the Martha T. Muse Prize for Antarctic Science and Policy. I'm Diane McKnight. I'm chair of the prize committee, and I'm pleased to introduce to you Ms. Renate Rini, who is the president and chair of the Tinker Foundation, which has graciously inaugurated this prize to advance Antarctic science, and she'll be giving us a perspective on the prize.
Good afternoon. It gives me great pleasure to be here today to award the first Martha T. Muse Prize for Science and Policy in Antarctica. More than 20 years ago, Martha Muse, the recently retired chairman of the Tinker Foundation, first visited Antarctica. It was love at first sight. From then on, she encouraged the foundation to fund many projects related to Antarctica, ranging from the hard sciences to policy issues of governance. The Muse Prize recognizes those specialists who have dedicated themselves to Antarctica and have not only demonstrated excellence in Antarctic science and policy, but who have shown a clear potential for sustained contributions that will enhance our understanding of Antarctica and promote its preservation for future generations. Of course, the establishment of an international prize takes a great deal of work, and I especially want to thank Dr. Michael Sparrow, Dr. Diane McKnight, the staffs of SCAR and the Polar Research Board, and the first Muse Prize Selection Committee for all of their hard work in designing the prize and selecting the 2009 recipient. Thank you also to Olaf Ordheim for allowing us to award this prize during this distinguished meeting. The first winner of the Martha T. Muse Prize for Science and Policy in Antarctica is Professor Stephen Chon. He clearly exemplifies the attributes of the prize, and I am most honored to be able to recognize his work. Professor Chon, if you would come up here, I'd like to give you the prize personally. We had this prize specially designed by Steuben Glass, and it will go to each of the winners of the Muse Prize for the next 10 years. And I think it looks really great. It's a piece of ice with the symbol of Antarctica engraved on it. Thank you very much. Congratulations.
Thank you very much. I really appreciate it.
And Professor Chuck Kennecott will give the citation, giving you an overview of the impressive accomplishments of the first awardee.
Your Serene Highness, Your Royal Highness, and all our invited guests, and Your Excellencies, I appreciate you coming today to hear from one of our very own, Professor Stephen Chon. And I thought I'd take this opportunity to tell you a little bit about Professor Chon. I know him more as Stephen. He's considered also a close friend. He's been an outstanding researcher and world-renowned advisor to the Antarctic Treaty System. So he very much epitomizes the policy and science focus that the Tinker Foundation has asked for in the Muse Prize. Professor Chon is from Stellenbosch University in South Africa, and as you've heard, he's the inaugural recipient of this prestigious Martha T. Muse Prize for Science and Policy in Antarctica. Professor Chon is a widely published and cited authority on invasive species and the effect of climate change and human interactions on Antarctica. The selection committee of leading Antarctic scientists and policymakers cited his outstanding contributions to both science and policy in Antarctica. Professor Chow plays a critical role in Antarctic policy by leading the delegation of the Scientific Committee on Antarctic Research at the annual Antarctic Treaty consultative meetings. His advice and leadership has been pivotal in advising policymakers in a wide range of environmental stewardship issues. And just to give you a little more information about Professor Chow, he's director of the Center for Invasion Biology and a professor in the Department of Botany and Zoology at Stellenbosch University. His research interests also span a very broad range, including invasion biology, which I already mentioned, biogeographic and macroecological studies, evolutionary physiology, spatial ecology, as well as the integration across these varied fields. He has interests not only in Antarctica, but also in the subantarctic islands and the biology and conservation of those locations. Just so that you know some of his accomplishments, this prize is for an early to mid-career, and I think Steve has exceeded all expectations for that. He's published more than 250 research papers in the primary scientific literature and written and co-authored numerous books and book chapters. So without further introduction, Professor Chow.
Your Royal Highness, Your Serene Highness, distinguished guests, friends, representatives of the Tinker Foundation, it's indeed a great honor for me to be with you here today and to discuss with you some of the work that I've been doing that has led to this award. At about this time of day, on the 16th of January 1840, past midshipmen William Reynolds and Henry Eld spied from the cross trees of their vessel, the Peacock, land. In so doing, they thrust controversially the United States South Seas Exploring Expedition into the chronology of research and exploration that has led to the legacy of an Antarctic science that we celebrate today. That scientific legacy has indeed been substantial. We know a great deal more about Antarctic biodiversity and the operation of Antarctic systems now than we did 50 and indeed 100 years ago. We also know that Antarctica is a critical element of an Earth system. We were not thinking of Earth systems before this legacy of research. We know that Antarctica is important in the global system, and we know that in turn the global system has an influence on Antarctica. Of course, while we were about establishing this legacy, the world changed around us, and we changed with it. During the third international polar year, the human population was approximately 2.9 billion. 50 years later, during the undertaking of the fourth international polar year, it's 6 billion. We have changed as a consequence of our aspirations and our numbers, the way our planet works. And indeed, we are now starting to recognize that this change has profound influences on us. We've heard a great deal about one of those changes today already, and that is climate change and the influence that changing climates are having on ourselves and on biodiversity. Both panels on the left-hand side will be immediately recognizable. These are rather famous pieces of research, even if the one by Hansen and others is a draft paper for discussion on the web. The panels on the right-hand side may not be as familiar to you. The top one indicates the number of alien species in Europe. Those are species that are introduced by human agency, that are, in essence, sometimes in the right place at the right time because we depend on them for agriculture, but at other times, the wrong species in the wrong place at the wrong time. And the bottom panel indicates the enormous increase in research interest as a consequence of the impact these species are having. In 1991, David Pimentel and a group of co-authors estimated that species that are in the wrong place at the wrong time are costing us about 5% of GDP. Now, of course, you know that doing those sorts of calculations means you need a margin of error, but even if that margin of error was 0.5% of GDP, that's a significant impact. And what I'd like to discuss with you today is how these impacts have been seen in the region in which I work. Let's start with climate change. The Antarctic Climate Change and the Environment Report produced by SCAR has many figures, of which this is one. It indicates that rapid climate change is taking place along the peninsula, but I don't want to dwell on this. I draw your attention to the report and suggest you read about that change there. What I would like to talk about is some areas that I've worked in. Most particularly, a small subantarctic island known as Marion Island that lies at about 47 south and is considered one of the associated and dependent ecosystems that the treaty recognizes. That is the Antarctic Treaty. On this small island that was annexed for strategic reasons in 1947 by the South African government in collaboration with the United Kingdom government at the time, the temperature has changed since the establishment of the meteorological station by about 1.5 degrees. That's over a 50 or 60-year period. The precipitation, the annual total precipitation, has declined by 600 millimeters. To put that into some context, that's the total annual rainfall we can expect at my home in Somerset West in South Africa has disappeared. That's a consequence of some changes that are taking place in the region more generally. And of course, the influence has been seen. When the 1965-1966 biological and geological expedition to Marion Island showed up, they reached the top of the island and found a glacier. By Norwegian standards, a very small glacier, but a glacier nonetheless. By 2009, that glacier had entirely disappeared, and along with it, the permafrost. The glacier had joined its smaller companions elsewhere in the world and left. Biologically, we have seen substantial impacts too. Looking at the vascular plants, those are the ferns and the flowering plants, we have found in this 50-year period, during which, in the beginning, in the 1960s, very good records were made of altitudinal or elevational distributions, vascular plants have increased, on average, their extent up the altitudinal gradient by about 80 meters. The winner in the race has extended its range by 380 meters over that 50 to 60-year period. That's sometimes a little difficult to comprehend when you're simply thinking of altitudes. The entire island is 1,230 meters high. But if you use a picture, the visualization is quite striking. So this small club moss, Lycopodium magellanicum, was first found down where you see the yellow arrow. That was the limit of its elevational distribution. Now on the east coast, you can find it all the way up there in 50 years. Of course, it's not only individual species that have moved, but the entire system has changed. At 400 meters above sea level, one used to find, and this is an image from the 1960s, essentially a fell field dominated by cushion plants with many bare areas. In 2009, we retook the picture as best we could, and it is now essentially a grassland. We are changing what was a polar fellfield ecosystem into a straightforward grassland. If one examines repeat photography, which can be really useful, one also finds on this small island that the streams have changed, but the change is a bit more subtle in the photograph. If you look carefully at this image here, you will see that the rocks have nothing on them in terms of vegetation. Whereas, of course, last year, they were completely covered in vegetation. And in fact, by a small species that you would hardly notice if you were walking around in Europe, the procumbent pearlwort, Sagina procumbens. It's an invasive alien species. Once introduced, it finds its way into the environment and indeed changes that environment. And that brings me then to the second of the topics I'd like to discuss with you today. Biological invasions in the region, this region of Antarctica and its associated and dependent ecosystems. To begin with, it's perhaps best to remember that one of the remarkable characteristics of Antarctica is that it is almost entirely free of alien species. This is not true of the rest of the planet. There is no place you can go to that does not have species that have established accidentally as a consequence of human intervention, except for the Antarctic and perhaps one or two of its smaller islands surrounding it. Of course, that doesn't mean that the area is alien species free. We have a wide variety of species established on the islands, some as a consequence of intentional introduction, such as reindeer on South Georgia, and others as a consequence of an accident. Nobody intentionally introduced slugs to Marion Island. There would be no reason to do so. Of course, this is not only true of these islands, but the concerns have extended themselves to the Antarctic continent. The small annual grass, Poa annua, has been found on King George Island. We have concerns about propagules, or seeds and reproducing individuals reaching the Antarctic via our activities. And of course, we have grave concerns about what an improving climate, at least from the perspective of some of these organisms, will do to the region. Some of the work that we started out doing across these associated and dependent ecosystems showed that the more occupants you have on a particular area, the more likely you are to end up with invasive alien species or alien species. And this, to begin with, seems like a relationship that's self-evident. It's certainly true for mammals that are shown here. It's true also for vascular plants, which mostly were not introduced for any purpose in the area. And it's certainly true of insects. Taken together with the following image, you really have an interesting recipe for change. This image is a compilation of the visits by ships to 3 islands in the region. The very far south Heard Island, which is owned by Australia, Gough Island, which is a United Kingdom island that's quite far north, and Marion Island, which I've spoken about. We've changed the way we get there, but we've also increased the numbers of visits. You will see, of course, that there's a substantial increase in the number of visits since about the 1950s. Just before the huge interest in working in these regions, stations were established, and the numbers of visits have increased ever since. Of course, you may be wondering what on earth went on here for Heard Island. Well, that's an example of resource exploitation. The island was discovered by sealers, and about 15 years later, the seals were used up, and they left, and the numbers of visits declined. If we look at these 3 islands and we look at the alien insect species that have been accidentally introduced, and we take those 2 time periods, 1955-66 more or less, and then very recently, we see that the numbers have more than doubled on Gough Island of established alien species, at least 10% of which are having quite a significant impact. For Marion Island, it's slightly less, and for Heard Island, of course, there's been no change. But the important point is Heard Island is a much colder island on average than these other islands, which are quite temperate. How we change the climate will change the probability of establishment success. Before moving on, it's perhaps also worthwhile to draw your attention to this particular figure. On Gough Island, the number of indigenous insect species is about 20. The number of introduced insect species that have established is about 70. We have increased the rate of establishment by between 100 to 1,000-fold, depending on how you look at the maths. If you think about the volume that was put out recently on extinctions, extinctions globally have increased by about 100 to 1,000-fold. So in essence, Gough Island is a clear example of what can be called the suburbanization of biodiversity. Of course, impacts extend not only to numbers. If you think about the small pearlwort that we met earlier, if you arrived on Marion Island in the 1970s, it was clustered around the station in a few localities, and everybody wondered what it was. Of course, going along a little bit, if you move to the next panel in the top right, that's 1987. What happened in 1987 is a large feral cat eradication program was established, and rightly so. Seabirds were being decimated by feral cats. That program increased the number of people working on the island by 5 times, and increased the travel around the island substantially. And what this did is it almost instantaneously spread the procumbent pearlwort right around the island. And you can tell that an increased team shown in the picture of the team in 86, 87 was repeated for about 6 years. And by the time we resurveyed in 2006, we found that the entire area had actually been colonized by the plant. The impacts also go further. This is an example from Macquarie Island. And for those of you who know, Australia is investing a vast amount right now in terms of eradicating cats from the island, rabbits from the island that have caused huge problems. So rabbits have caused problems on several occasions, but most recently, they have caused problems as a consequence of a management intervention we have made. So if you look at the change, this is a site dominated by a megaherb, Stilbocarpa. A few years later, the megaherb is gone and we have erosion. If you scale that up using a difference between two satellite images over the same period, all the red areas are areas where primary productivity has declined because the plants have been removed more or less. The rabbits exploded because the cats were eradicated, and again, rightly so. And this is no criticism of eradication programs. What it is a lesson, is a simple and an old one, that prevention is much better, much simpler, and much more cost-effective than cure. I've been speaking about terrestrial systems, but like icebergs, we have some problems down below too. Marine vessels, and the South Africans have been very generous in allowing us to investigate their research vessel, carry non-indigenous species into the Antarctic. The organisms you see illustrated in the lower panel are in fact Mediterranean mussels that invaded South Africa, then colonized our ship, and have been going back and forth to Dronning-Maudland quite happily. They seem to have done quite well, thank you very much, in the sea chests, even though those sea chests, we are assured, are not warm. They are the intakes for the ship's systems and are quite as cold as the water that the ship is sailing in. So that's some of the science. And the question is, what has it taught me specifically about policy? Well, the first thing to remember is to remember that over the 50-year period, which is a short period, it's a human lifetime period easily, between the third international polar year and the fourth one, we have significantly changed what we do on the planet. And I think this extends to every endeavor, including citation rates and the vast difficulty we have in keeping up with the published literature. For me, in terms of climate change, much has been said about climate change and policy, and particularly recently, as a consequence of the political events that have unfolded over the last year. This figure that comes from the Antarctic Climate Change and Environment Report put it together, summed it up for me. The world really is very much connected. What we do in one area affects another area. So how we change one area, and that signal of change, indicates that our change will have effects on biodiversity and livelihoods in Africa, on cultural diversity and livelihoods in Europe, and on the way of living and on biodiversity in Australasia. We can't afford to ignore that message. But Tom Friedman, in the recent release of Hot, Flat and Crowded, which he called Release 2.0, indicated that we simply aren't doing sufficient. I know that it's easy to say so, very easy from a scientific perspective to say so, but we would take his warning well, that we need to do a great deal more. It is insufficient to go to a meeting of experts, formulate 15 to 20 recommendations, and walk away having hesitated at the last of the hurdles, which is to resource those recommendations so that they can be fully implemented and to realize that some of this is going to hurt. For biological invasions, it seems a little easier. We know what the vectors and pathways are, the routes into the area. We've documented them. We've documented them to such a degree that the management can actually be finally done. It's no surprise that you'll carry more seeds on your socks. It may be a bit of a surprise that camera bags are really awful for distributing invasive alien species. And the little inset, which you won't be able to see very clearly in terms of what it says, the numbers of seeds are much higher in personal gear than they are in the gear issued by the national Antarctic operators. In other words, your operator's gear is usually much cleaner than yours. The International Polar Year Aliens in Antarctica program has produced a vast variety of results, many of which you can hear about on Friday. But perhaps key for me was this result. If you look at tourists, 21% of them carry seeds. And if you look at field-based scientists, 53% of them carry seeds. we need to think very carefully about which routes of entry we need to manage. But things are not just as simple as keeping organisms out of Antarctica. The environmental domains of Antarctica, which was commissioned by the New Zealand government and done by Morgan et al., showed that many of the areas in Antarctica share the same climate. In other words, if you took organisms from one area to another, they wouldn't stress as much as if you took a temperate organism into the Antarctic. And we know from plenty of biogeographic work that there are real divisions in the area, divisions large enough to deserve a name, similar to the Wallace Line. Moving organisms around in the Antarctic will cause trouble too. And we know we don't know enough about how those organisms are distributed at the moment, simply by the number of records increases, the number of species increases, which means that you haven't surveyed properly in your particular area. But we do have quite a lot of policy that's been developed elsewhere. We have management tools that have been developed because this is not a problem restricted to the Antarctic. We have specific tools for the Antarctic region too. And of course, we have some very specific guidelines that have been given to the Committee for Environmental Protection, the instrument that informs the treaty about environmental matters. So for me, it was a little surprising then to see this statement in a recent paper on the grass poa annua. It's found on King George Island. It was first seen in 85, 86. There were more in 91, 92. And there were more in 2006, 2007, and they started invading non-disturbed localities. Nowhere in the paper does it say, oh, in between we had a huge effort to try to remove the species as fast as we could. And I think that whilst we've all acknowledged that we have 2 vascular plant species on the Antarctic Peninsula, indigenous ones, we may end up getting a 3rd, which will spread quickly. It is the most invasive grass across the associated and dependent ecosystems. Drawing to a close, I'd like to remind you that this is a very special place, Antarctica. It's special in terms of the fact that it has no alien organisms at most sites, at least that we know of. And I'd like to draw your attention to 3 statements. The first is from Article 2 of the Protocol on Environmental Protection to the Antarctic Treaty. And it says that the parties commit themselves to the comprehensive protection of the Antarctic environment. The second is by Carrick from the first SCAR Biology Symposium. And he said, essentially, the same message that Al Gore had in his 1992 book, Earth in the Balance: we need good science and we need strong policies. We have a lot of the science, but clearly there's a lot of way to go. But we do need good policies. And if you read Clive Hamilton's most recent book, he's a professor of public ethics in Australia. He says we really do need good, strong politics enforced by governments. This is not something that individuals can do on their own. And so, in future years, I hope that in 50 years' time, when the next generation of scientists, the heir to our scientific legacy, turn up for a spectacular open science conference, as the Oslo Science Conference is, that they turn around and they say, that 4th International Polar Year really changed the way things are done. We succeeded as scientists, we succeeded as people. We do not have the problems that our ancestors envisaged we might have. And so, Your Highnesses, ladies and gentlemen, I would like to thank the Tinker Foundation for establishing this award and the committee for selecting me initially to receive it. I'd like to thank the many people who have supported me throughout my scientific career. And of course, I'd like to thank the organizations that have funded this work. They have been instrumental in ensuring that we can do some of this. And finally, Your Highnesses, ladies and gentlemen, thank you very much for your attention.
Thank you very much for your inspiring presentation, and I appreciate that you'll be here during the rest of the conference, and encourage those of you who have questions to approach Steve, and he'll be glad to tell us more about what he's doing. At this time, I'm pleased to introduce His Royal Highness Prince Albert II, and I last met you in Scott Base in Antarctica, so it's a pleasure to see you again here in Norway.
Your Royal Highness, Your Excellencies, ladies and gentlemen, dear professors, dear friends, I'm delighted to be here in Norway and in Oslo for this outstanding conference, and I'd like to congratulate the organizers for putting on such an outstanding group of people who have gathered here. I'd like to begin by also congratulating Professor Chown for his accomplishments and for this award that he has so deservedly won on his exemplary career in the service of science and the environment, career combining scientific work with commitment in international institutions like SCAR. It is a sad thing to consider that nature talks and mankind doesn't listen, wrote Victor Hugo. Through your work and your commitment, dear Professor Chown, you were not satisfied with only listening to nature. You also strove to make mankind listen. This immense quality is the main key to success for all initiatives in the service of protecting our planet. I'd also like to thank everyone for giving us this opportunity, a year after the end of the International Polar Year, to take stock and especially pursue our mobilization. In my turn, after the very apt statements were made here by previous speakers, I'd like to highlight the exceptional mobilization of the scientific community. I'd like to pay tribute to the men and women from over 70 countries who are engaged in the adventure of this past polar year to show us the way toward responsible action. It is to them that we owe all that has been achieved and all that we can understand and share from what the polar year has brought to us. Yet, despite the mobilization and major advances achieved thanks to this polar year, the situation at the poles remains disquieting. The alarm signals are still flashing, and we have the uneasy feeling of not really progressing in the decisive fight against global warming. The failure of Copenhagen was indeed a disappointment for everyone. All the more profound, perhaps, for the Arctic region, whose situation continues to worsen. We have to admit that our determination has little weight in the face of inertia. Far from discouraging us, this realization should entice us to intensify this mobilization and help us be more vigilant to explore all means of action. Indeed, such action is possible. Today's reality is not tomorrow's inevitability. This polar year has proven that mankind is gradually becoming more aware of the looming threats. It is up to us now to pursue this path forward toward global action that can be effective only if it brings together all the states and organizations concerned. I'm obviously thinking at the forefront of Norway and the 8 circum-Arctic countries whose role is of primary importance. But this commitment, which concerns a good shared by all, should bring together all goodwill all over the planet. Every state, every competent organization must contribute to this struggle. In this respect, I'm pleased that my foundation can participate, however modestly, in this action, thanks in particular to the agreement we will sign in a few minutes with the University of the Arctic. Everyone must make an effort here to preserve these regions that are indispensable to all of us. Altogether, we must learn to set aside our selfishness, interests, and habits to rally around a cause that should unite us all. In the Arctic, perhaps more than elsewhere, this year of international biodiversity should incite us to advance by using all possible means in the rapid creation of protected marine areas, even in the open sea. And I stress this point particularly today as we are celebrating World Oceans Day. This is a sphere where international cooperation is necessary and can lead to significant advances. As my country, Monaco, showed so well over 10 years ago with our French and Italian neighbors in the context of the Pelagos Marine Sanctuary. At the same time, we must also look to the peoples who live in the Arctic and who are the first victims of the disruption caused by others. I'm thinking, of course, of the direct damage to their environment and natural resources, but also to the profound changes in social customs and mentalities, those silent revolutions that upset this delicate balance, and this delicate balance between traditions and the necessities of modern life. Ladies and gentlemen, we must reposition these populations at the heart of the debate and never forget that the major concern is man and man's place in nature and his ultimate survival. Damage to the environment always entails damage inflicted on humanity. All these issues, I want to assure you here of my country's total commitment on the entire international scene. Wherever it is present, the Principality stands side by side by all those who work toward conservation in both polar regions. This commitment is valid for both the Arctic and the Antarctic. And this is why I'm so pleased that Monaco will, I hope, soon be able to join SCAR. And this is also why I wanted to be here to share with you this moment of hope and determination. Some 2,500 years ago, the Greek philosopher Heraclitus said, "Those who are awake have one world in common, but those who sleep turn away each to a world of their own." That is, above all, the role of the International Polar Year and the role of this conference to maintain awareness so no one can forget that this world, our world, is one and something we all share. Thank you very much. Have a wonderful conference.
Well, I think we will be meeting again at various sessions at 2 o'clock, and I wish you all an enjoyable lunch.